Have you ever wondered where everything around you, from the tiniest atom to the farthest galaxy, came from? As humans, we've always been captivated by the universe's infinite grandeur, its silent mysteries, and the cosmic dance of celestial bodies. But where did all these come from? The answer lies in the creation of the universe, a tale that weaves together the threads of physics, cosmology, and yes, even a sprinkle of imagination. So, buckle up as we embark on a journey to the very beginning of everything. Imagine, if you will, a moment when nothing existed, not even space or time. This is where our journey begins, at a point of infinite density and gravity, known as a singularity. This singularity is no larger than a pinprick, yet it contains all the matter in the universe. It's like every grain of sand, every mountain, every star, every galaxy, all squashed into a space smaller than the period at the end of this sentence. Hard to fathom, right? But hang on. The ride is just beginning. In a fraction of a second, this singularity explodes. It's not an explosion like a firecracker or a supernova, it's the explosion of space itself. It's the Big Bang. A better term might be the everywhere stretch, because from that singularity, space begins expanding in all directions. Imagine you're on the surface of a balloon as it's being blown up. No matter where you are on the balloon, everything else is moving away from you. That's what the universe is doing. It's expanding, getting bigger and bigger. Now, this isn't an instant process. The universe didn't just pop into existence fully formed. It started out as a hot, dense soup of particles, too hot for atoms to form. But as the universe expanded, it cooled. It went from being unimaginably hot to merely exceedingly hot, and then to just really, really hot. Over time, particles began to stick together, forming the first atoms. These atoms then began to clump together, forming the first stars and galaxies. This process took billions of years, but it all started from that initial explosion of the singularity, the Big Bang. So, from a point smaller than a grain of sand, the universe expanded into the vast, complex, beautiful cosmos we see today. And it's still expanding, still growing. Every second, the universe gets a little bit bigger. And just like that, from an infinitesimally small point, the universe was born. In the aftermath of the Big Bang, the universe was a hot, dense soup of particles. Just imagine a cosmic kitchen where the recipe for the universe is being cooked up. In this cosmic kitchen, the heat was so intense that particles were whizzing around at incredible speeds. But as time passed, the universe began to cool down. It's like turning down the heat on your stove. Things start to simmer down. As the universe cooled, these particles began to slow down and combine. This was the universe's first bonding party. It was during this time, around a few 100,000 years after the Big Bang, that the first atoms were formed. Now you might be wondering, what were these first atoms? Well, they were none other than hydrogen and helium, the simplest and lightest of all elements. These atoms are like the flour and sugar in the recipe for the universe, essential building blocks. Hydrogen and helium are simple, with just 1 and 2 protons respectively, but don't let their simplicity fool you. When these atoms combined, they set the stage for the formation of all other elements. From the carbon in our bodies to the silicon in your computer chips, it all started with hydrogen and helium. The universe continued to cool and expand, and these atoms began to clump together, eventually forming stars and galaxies. But that's a story for another time. With these first atoms, the universe had the ingredients it needed to make everything we see today. The universe was not always filled with the stars and galaxies we see today. Once upon a cosmic time, all that existed was a vast expanse of space filled with atoms, primarily hydrogen and helium. These atoms were not content to float about aimlessly. No, they had a destiny, and that destiny was guided by a force we're all too familiar with, gravity. Gravity, the great cosmic architect, began pulling these atoms together. As more and more atoms got cozy with each other, the pressure and temperature at the center of these gatherings began to rise. This process, known as gravitational contraction, eventually led to conditions hot and dense enough for nuclear fusion to ignite. And voila! A star was born, but stars, like people, enjoy company. So these stars began to gravitate towards each other, forming clusters. These clusters of stars, bound together by gravity, eventually grew and evolved into galaxies. Now let's talk about the life cycle of a star. Stars like us have a lifespan. They're born, they live, and eventually they die. But the death of a star is not an end. It's a spectacular transformation. When a star exhausts its nuclear fuel, it undergoes dramatic changes, resulting in a supernova explosion. This cataclysmic event releases a tremendous amount of energy, And it also creates and disperses heavier elements such as carbon, nitrogen, and oxygen into the universe. These elements are the building blocks of life as we know it. So you see every atom in your body, the air you breathe, the screen you're looking at right now, was once part of a star. We are, quite literally, stardust. And so from a hot, dense point, the universe expanded and cooled, forming atoms, stars, and galaxies. It's a cosmic journey of creation, from the tiniest atom to the grandest galaxy. And it's a journey that's still unfolding, billions of years after it began. Fast forward to today, about 13.8 billion years after the Big Bang. Our universe is a bustling metropolis of galaxies, each harboring a multitude of stars, planets, and possibly life. It's a cosmic dance that continues to bewilder and fascinate us. Our universe isn't just sitting pretty though. It's stretching out in all directions like a cosmic balloon being inflated. This ongoing expansion is a direct consequence of the Big Bang, and it doesn't show any signs of slowing down. Looking ahead, scientists have proposed several possibilities for the future of the universe. Some suggest it will continue to expand forever, growing colder and emptier. Others predict a more dramatic end, with the universe collapsing in on itself in a big crunch. As we look up at the stars, we are seeing the story of the universe unfold. From nothing came everything, a story of creation written in the cosmos.